Right, so we're going to look at geometry, and geometry is a lot to do with kind of lines, angles, shapes are kind of the main things we're going to be looking at. So lines, angles, triangles, your quadrilaterals, and kind of how the angles and lines and things like that work within those different shapes. So there's a lot of kind of just like foundational stuff to go over, and a lot of these things should be things that things you know from junior cert, things that you've used that you mightn't realize are kind of specific rules. So we're going to go over a lot of those in this kind of video, over things to do with lines and angles specifically, and then a lot of those things will be used down the line when we're looking at the shapes and when we're looking at triangles and when we're looking at different questions down the line. You'll need to use a lot of these rules as well, so it's kind of moving between or setting up a lot of those later things as well. So we'll look at some of the questions kind of from your book. We've an exam question or two to look at as well, and we'll go through those few ideas. So going quickly through some of these points then. So a line is a straight, infinitely thin, one-dimensional figure that continues forever. So a line goes on forever in both directions. A ray is part of a line that starts at one point and then goes on forever in the other direction. So like this one here starts at the point A, goes forever in the other direction. Points that are on the same line we call collinear. So collinear means that they coexist, I suppose, on the same line. Perpendicular lines meet at a right angle, and we should kind of know that symbol for right angle. So that little kind of backwards L or kind of L there, or sometimes we see it put in like that as well, meaning right angle. So either or. A line segment then is part of a line that has two endpoints, and we would call our line segment like below AB with the two kind of the two square brackets, or BA, and that the square brackets show where the line stops. So if we think about this ray up here, we could write that as being maybe A, B if it went through the point B here. So that shows that it has an endpoint at A but continues on past B. So again, all this kind of notation that should really be familiar to us at this point. Our notation here with the two straight lines for AB means that we're talking about the distance or the length of that line segment AB. So we said perpendicular lines there meet at right angles. Parallel lines are lines that have the same slope and they never meet. So they are the same distance apart at all points because they're never going to meet. Because if this distance was different, then they would be kind of, if that distance was any way different, then they would be kind of aiming towards each other at some point. But if they're the same distance apart, they're like train tracks, they never meet each other and they run parallel to each other then. Looking then at some stuff to do with angles. So an angle is formed when two lines meet. There are a number of different ways that we can name an angle. So looking at these ones here, we call that first one ABC or angle ABC, or kind of the angle symbol with CBA, so long as the letter in the middle is the one where the angle kind of exists. So we talk about it being from A to B to C or C to B to A, but keeping that B in the middle shows that that's the angle we're talking about. And we see that maybe in the next part where we just call it angle B, or if it was called 1, we might call it angle 1, or if it was called theta, we might call it angle theta. Okay, so again, the same idea. And the same idea applies then as we had with the line segment, whereas if I say the two straight lines and angle theta, I'm talking about the size of that angle. Okay, so how big is that angle? Different types of angles. We can have a null angle, which is 0 degrees. Acute is between 0 and 90. Obtuse, 90 to 100. A right angle of 90 degrees. Reflex is between 180 and 360. Our full angle, our full circle is 360 degrees. A straight angle is 180. This probably is one of the kind of first kind of points just to really make sure that we know. So supplementary angles are two angles that add up to 180 degrees. So like we have here, if you have 110 plus 70 on a straight line, that will add up to give you 180 degrees. But we can also have, like we have in this example, where we maybe have one angle up here which is 120, and we have another angle down below which is 60, and those would be considered to be supplementary angles because they will add up to give 180 even though they're not beside each other. So that's something to be aware of, and that's a rule that we might end up having to use in our questions. And again, this is kind of what I'm talking about when I'm saying that there are a lot of these rules that we probably are using that we maybe just don't explicitly know the name for, or know why they're kind of why they are the case, or realize that they are kind of a named rule. So moving on kind of quickly, I know I'm zooming through some of these points, but a lot of it is just setup. So looking at theorems then and axioms. So we have some key words here. So a proposition is kind of a statement in maths that might be true or false. We're proposing something. We're saying that this could be the case. A proof then is a series of logical steps that we use to show that a proposition is true. Okay, with all of these words, I suppose it's a good idea that you have some sense of what they mean, and whether that means learning off these definitions if that works best for you, or just having a general sense that you could express what each of these words would mean. If they asked what is a proof, that you could get across the sense of what it means. So a proof should have some logical steps, and we use it to show that a proposition is true, to show that something is true. An axiom then is a statement that we say is true without proof. Okay, there are a few axioms that we use, and they are just statements and they are taken as true. A theorem then is something that has been proposed that can then be proven with axioms and with logical arguments. And sometimes we'll use earlier theorems to prove later theorems that we might have, because we generally take them in a specific order so that everybody kind of knows what theorem we're talking about if we gave a number. Not that we really do, but just for ease of kind of writing about them. And usually the case is that we can use a previous theorem to prove one that comes later down the line. So using those theorems, using axioms, using logical argument, we can prove a theorem is true. So an axiom is always taken as true. A theorem can be proven to be true. A corollary then is a statement that follows from a theorem. So if I say that if I have a theorem and it proposes one thing, that might mean that something else is also true, and then that would be a corollary that follows from my theorem. A converse then is the reverse of a theorem. That's the opposite of a theorem. So that's like saying all the angles in a triangle add up to 180 degrees, and then if you went the other way around, well, the converse doesn't really work for that one, but it's things like that. It's taking one version of it and then going the other way. So one of the ones we look at would be for, say, alternate angles, that alternate angles will be the same as each other. And then if you said on the opposite side, then if you have two parallel lines and if the two angles are opposite each other, or if you have two lines and then the alternate angles are equal, that must mean that the lines are parallel. So that's kind of how it goes. It's changing the order of the words, I suppose, and taking kind of, if A means B is true, then B means A is true. Then implies we use in proofs, and it's writing something that's been proven by the previous statements, and the symbol is that kind of arrow. So it might be saying something and then that implies that something else is true. So there's 5 main axioms that we use, and as I've kind of said, a lot of these are probably familiar. You probably do know them, you just mightn't have seen them kind of listed out. And you don't need to learn how to state. You're not going to be asked what is axiom 1. You just need to be familiar with the kind of concepts involved in them, just so that you kind of know and are happy that these are accepted kind of true things. So the first one is there's exactly one line through any 2 given points. Okay, fairly straightforward. We can't draw more than one line through 2 points. The second one, called the ruler axiom, is that distance is never negative, so distance can only be positive. If C is on AB between the 2 points A and B, then if I add up the distance from A to C and the distance from C to B, that will be the same as the distance from A to B. Again, fairly straightforward. And then given any ray from A and any real number K, there is a unique point B on the ray for which the distance from A to B is equal to K. So all that means is if I have a point A, and if I draw a line and pick any number, say 5, then there's some point B that will be a distance of 5 away from A. That's all it means. Okay. Number 3 is called the protractor axiom, and that is that the number of degrees in an angle is between 0 and 360. So again, straightforward enough because that's a full circle, a full revolution. A straight angle is 180 degrees. All the angles at a point add up to 360. So again, that comes back to your circle. And then if we're given a ray and a number between 0 and 180, there's exactly one ray from A on each side of the line AB that makes an angle D degrees with the ray. Okay, so again, a lot of these points that are kind of, I suppose, that we use fairly frequently, really. Axiom 4, sorry, is not the protractor axiom. And then let's skip over. So axiom 5 is our axiom of parallels, and that is that given any line L and a point P, there is exactly one line through P that is parallel to L. Okay, so again, straightforward enough. So given any line L and any point P, then there's another line through this point P that would be parallel to the line L. We can only have one of those lines. Okay, axiom 4. So those are kind of your main axioms to look at. So your kind of 2 points, your ruler, protractor, the parallel lines, those kind of things. Axiom 4 is to do with triangles. We'll come to that one. We'll come to that one later. I don't know why I don't have it written in properly here, but anyway, we're gonna move past it. We're gonna keep going. So in terms of theorems, there's 21 theorems that we have to know. And I say no, we have to be familiar with, we have to be able to use them. And we've 6 corollaries that come from those as well. And we'll see these in later sections. We'll be using those theorems. And we don't have to prove any of these theorems at ordinary levels. We don't have to give a formal proof of any of them. We just have to know them enough to be able to use them in answering our questions. So the first theorem, vertically opposite angles, we're going to look at. Isosceles triangles, the angles opposite equal sides are equal. Alternate angles, angles add up to 180 in a triangle. So there's a lot of ones here that we'd be familiar with. The triangle inequality is a good one. So 2 sides of a triangle are together greater than the third side. So we're going to see a lot of these in the later sections. But it's worthwhile just having a read over those for yourself. Have a read over these theorems. We can see theorem 14 there is Pythagoras' theorem. So a lot of them are ones that we would be familiar with, that you would have seen before. Again, you just mightn't have listed them out as a theorem, but it's good to know that these are kind of accepted rules, or rules that have been and can be proven, so you're free to use them in your own proofs then when you're proving different questions or when you're trying to work out different angles and things like that. So worth having a read through those for yourself, just to make sure that you're kind of happy with them, I suppose. Looking then at the next section, I know we've a fair bit to get through. We're gonna just finish off with this section. So looking at, again, angles and lines, that's kind of where we started in the first section. So if we look at a straight line, so as we said there, one of our theorems was that when angles meet on a straight line, they add up to 180 degrees. And that's a really important rule to have. So if any sort of straight line and any other lines that meet, then if we add up all those angles along that straight line, we should get 180 degrees. And we can use that then, if we have 2 of the angles, we can use that to find the last angle. So that one comes up fairly regularly as one that's worth knowing. The next one then, when angles meet at a point, they add up to 360. So it's kind of step on from that one. It's if instead of just having it a straight line, it's when we're meeting at a point in the middle, all the angles then in the circle would add up to 360 degrees. The next part now is called vertically opposite angles, and that's when we have 2 angles like this here, and we can see I've marked them in with particular colours to show which ones are equal to each other. So if 2 angles are facing each other, opposite each other, at 2 kind of crossed lines, then those angles are equal to each other. So the 2 green ones here and the 2 red ones are equal to each other. And similarly then, because it's on a straight line, this green and red one would add up to be 180 degrees. So that's kind of where we can sometimes put our rules together. Looking then at alternate angles, if a transversal is a line, okay, it's this line here. So if we have a line that goes through 2 parallel lines, then the alternate angles formed will be equal. And we think of this Z shape when we're looking at alternate angles. So what we mean is those 2 angles I've marked in red, they will be equal if those 2 lines are parallel. And the converse, we said the converse was kind of the opposite of a theorem. So the converse is if those 2 red angles are equal, then that line is cutting through 2 parallel lines, because if they weren't parallel, those red angles might not be equal. Keeping going then, corresponding angles are where we think of this F shape, and it can be a backwards F like we have here in the diagram, or we could do similarly kind of a green here and show that these 2 blue angles, sorry, the wrong one there, working in the wrong one. These 2 blue angles, we could show that they are also equal to each other. And it's the same idea. If we have a line going through 2 parallel lines, then the corresponding angles are equal. The ones formed with those F shapes are equal to each other. Then interior angles are slightly different. So again, we kind of get this kind of C shape. It's kind of a kind of straight C. And with interior angles, it's not that the 2 angles are equal, it's that they add up to 180. And it comes from kind of the 2 rules that we've looked at already. So if we look at this example here, if I was to shade over this with my corresponding, with my F shape, I could mark in another red angle here to match this one up here and show that those 2 are equal. And if those 2 are equal, then this red one and the green one here would add up to be 180 degrees. So it kind of comes from the same idea that we have there. And the note I've put in here is quite important as well. When you're solving problems, you should be saying what the names of these rules are. So if there's a reason that you think angles are the same in a particular question, then you should give that reason in answering the question. So looking at this one here, so we want to find the measure of any of the unknown angles in the following diagram, and we have to give any of our rules that we use. So there's loads of different ways we could answer these questions, and there's loads of different rules we could use to answer them. And we can start with any of the numbers. What we might do is we'll start with number 3. So I'm going to say that angle number 3 plus 60 degrees should be equal to 180 degrees. And that was our supplementary. That was kind of the rule we had. Or you could have angles on a straight line. So really angles on a straight line, I suppose, is the more obvious of them. They're on a straight line, so they should add up to 180. And that's going to mean then that angle 3 is 120 degrees. Okay, so we've worked that one out, so that's 120 degrees. Then what we could do is we could look then at this kind of shape here, and just to kind of show, I suppose, a less obvious one. So we have a shape here that is actually that F shape we were talking about, but this time it's kind of upside down, altogether upside down and flipped the wrong way around. But it is still the same F shape, and what it means is that angle 3 will be the same as angle 1. Okay, so we can say angle 3 is equal to angle 1, which means that angle 1 is equal to 120 degrees, and that is called corresponding. That is because they are corresponding angles. Okay, and you can see I'm giving my little reason for each of these rules then. We look at then, so we've got angle 1 being 120 degrees. And then in a similar way, we can do the same thing here with angle 60 and angle 2. So we get that angle 2 is equal to 60, sorry. Not angle 60, just 60. And again, that is because they're corresponding. Okay, so they're corresponding angles. So this is 60 degrees. Okay, so now we might want to use maybe one of our other rules to find one of the other angles. So just to kind of show it off. So let's try and get angle 5 then, and this time we're going to use our Z shape. And we will get that angle 5 is equal to 60, and that is from alternate angles. That is from them being alternate angles. So angle 5 here would be 60, and still works out then that angle 5 and angle 3 add up to give 180, which was our interior angles. So we're happy enough with that one. And then the last one we need to find, so we found number 1, we found number 2, we found 3, 5, so we just need to find number 4. So again, we could use that number 4 plus number 3 should be 180, which means that number 4 is equal to 60. Okay, and another way that we could have done that one actually, now that we look at it, is that angle 4 is equal to 60 because they are vertically opposite. Okay, and if we can see that one for yourself as well. So what I'm saying is that these two are opposite each other in that cross. So we have 60 here, and this is my number 4. So these two are going to be equal to each other. So lots of different ways to answer. And that's the case with a lot of these questions. Sometimes you can use any different number of different ways to answer these questions. And it's just making sure that you're kind of happy enough to do so. And listing out your reasons after each of them. So looking at this one here then, so this was taken from a junior cert paper just to give you some practice of answering these questions and just to give us a few more questions to work with, because some of the Leaving Cert ones obviously use more of the later rules than just these ones. So here we're looking at this angle DBC is 50 degrees, find the value of x. Well, I suppose the first thing is that 2x plus 3x plus 50 is equal to 180, and that's because they're on a straight line. So we get that 5x plus 50 is equal to 180. So 5x is equal to 130, and x is then going to be equal to 130 divided by 5, which is 26 degrees. So we were just asked to find the value of x. We weren't actually asked to find the value of those angles, just x itself. Then looking at the next part, AB is parallel to CD, BC and AD intersect at the point E. Prove that the triangles ABE and CDE are equiangular. Okay, equiangular or equiangular, have the same angles. So we're looking to prove that this triangle ABE, which is the yellow here, and this triangle DEC, this one here, have the same angles. Okay, so we want to show that they have each of the same angles. So let's just pick one of the angles first. I'm going to start with angle E here. Okay, So I'm going to say, first of all, that angle B, let me go, so the size of angle BEA is equal to the size of angle DEC. And that is because they are vertically opposite. Okay, so those two I've shaded in red there are vertically opposite each other. We said that was the one with the cross. So when we have that cross, if the two are opposite each other, then they're equal. So that's something that's going to be important. Okay, so they're going to be equal to each other. We don't actually have to come up with the actual reasoning behind it, I suppose. So we're happy enough that those are equal to each other. We want to show now that some of the other angles are going to be equal to each other. So let's pick one of the other angles and try and show this same idea then. So we're told that AB, which is this line, is parallel to CD. And having parallel lines opens us up to using all these rules we talked about up here, because we can see that all of these rules require us to have parallel lines. Okay, bar those vertically ones. So from alternate on here, so alternate, corresponding, and interior, for all of those, we have to have parallel lines. So we can't use those until the lines are parallel. So we have that with this question. These two lines are parallel. So because of that, I could say that this angle in orange here is going to be the same as this angle in orange here. Okay, so we can write that down. So let's say angle AB, or we'll even just call it angle B, is equal to angle C, and that is because they are alternate angles. And similarly, we can say that angle A is equal to angle D, and that is because they too are alternate angles. Okay, and if you're just not able to see that, we'll mark it in here. So let's get rid of these here for a second. So drawing my little Z shape down here. Okay, and we can color that in there. So that's showing that these two orange ones are equal to each other, and we can do the same thing then for A and D. So starting from B here, doing my little Z shape down this way and back across, and I'm showing that this angle and this angle at D are equal to each other because they're alternate to each other as well. Okay, so what we can see, I suppose, and what's important with these ones is making sure you're happy with all those rules, that you're able to list them off, that you're able to put them down when you use them in a question, that you're able to write down what rule you've used, that you can recognize when to use each of these rules. So I suppose primarily focusing from here, the straight line and meeting at a point, that's probably the ones that we're fairly familiar with, that they add up to 180, they add up to 360. The vertically opposite is one that is used a lot. You just need to remember, look for that X shape, and then the ones opposite each other will be equal. Alternate, interior, and corresponding, you must have parallel lines before you can use those, and that's probably the main thing or the main issue people run into, is trying to use them when they don't have parallel lines. So just make sure that when you're using those ones that you have your parallel lines. And otherwise, it's making sure, again, as we said, that you maybe just read over those theorems, read over the axioms, making sure you're happy with all of those and able to use them then in answering your questions.